Welcome to this exhibition of paintings by the famous German poet Johann Wolfgang von Goethe and the French artist Auguste Herbin. All works are exclusively in ideal colors. Looking around, you may feel disappointed. Everything is in black and white. There are no other colors to be seen. Let be that absolute white and black can be regarded as ideal colors. But be patient. You may occasionally have seen one of these small rainbow-colored spots of light appearing on a wall when the sun shines through a prism. When Goethe in his time got a prism in his hand, instead of sending light through it, he tested to look through it. And what he then saw, he found remarkable. Take a look at this glass sculpture, in itself completely colorless. Immediately the most enigmatic colored shapes appear on the glass. To understand a bit more of what is actually going on here, look into the dark corner over there, where the sun shines in through a window. Colors appear where the bright path of light borders on the shaded areas. It struck Goethe that a confrontation and interplay of light and darkness might be a necessary condition for colors to appear. To follow up this idea, he arranged a number of simple geometrical patterns in black and white. He reported his findings in a booklet, Contribution to Optics, and attached a number of pictures meant to be regarded through the prism. A selection of these are shown on the walls here. Before you go around, let me give you some advices. Look at the first picture. It is just an arbitrarily drawn line. If we look close, like this, there are relatively thin color borders. In fact, if sufficiently close you see no colors at all, of course, because there are no paints on the surface. You have to look from some distance, and the further away you are, the more coloration you get, until the whole image gets blurred and confused. So for each picture there is an appropriate distance you have to find out to get the best view of it. Already Aristotle pointed out that vision needs distance. Another thing you observe is that colors appear where the line runs horizontally rather than vertically. This is clearly seen on the picture with the circular discs. It is due to the fact that the prism is oriented horizontally. Note here also the symmetry. The black disc on white ground has blue on the upper edge, while the white disc on black ground has yellow on the upper edge. Next, take a look at the second picture on the wall. You may feel a need to see it rotated. We have produced a device where you can study patterns rotated. Here you have the checkerboard pattern. Goethe advises us to look at just one single square, say a black one on white ground. You see that two spectra appear at the transitions between black and white. On the upper side you have turquoise plus dark violet. On the lower side, yellow plus red. If you look at the inverted picture, that is a white square on black ground, you see essentially the same boundary spectra, joining bright and dark. Now with changed positions. And note that yellow and turquoise are in any case closest to white, red and violet to black. The next demonstration is of fundamental importance. Here we make the boundary spectra meet and partly join. It can be done in two ways. In the first case, we make yellow and turquoise meet, giving rise to green, and finally darkness. In the second case, we let red and violet meet, giving rise to purple, and finally ending up in white. Green and purple, two new members in our system of ideal colors. Rotating this figure, you will see the two spectra simultaneously produced. Note that a narrow black or white strip gives rise to spectra that are several times broader. As Goethe says, the colors seemingly radiates out from the thin strip of white or black onto the surrounding background. Finally, take a look at the zigzag pattern. At a distance, it is adjoining rows of purples and greens. But when we turn the pattern, it opens up and shows the underlying yellow-red and blue-violet boundaries. The first picture on the back wall illustrates the basic principle of ideal colors. It simultaneously shows the two boundary spectra and their increasing overlap where green and purple are created. In fact, colors of all possible hues in various saturations are found here. This is the wonderful property of ideal colors. Each color has its specific position between white and black, that is, a given inherent content of light and darkness. Goethe sometimes called them absolute colors and original colors. Next follows a row of more or less playful patterns. On the third wall, we find 5 pictures designed by Auguste Herbin and presented in his book from 1949, L'art non figuratif, non objectif. The first two are geometrical patterns, adapted to the horizontal-vertical principles of coloring. The next two are circular, struggling against this principle. And the final one is an intricate composition of esoteric look. Here at close scrutiny, and here, perhaps, at optimal distance. Herbin supplied a table of theses on light and color, from which I have selected 6. The first one, La couleur, c'est de la lumière matérialisée par l'obscur, sounds very deep, which is typical of philosophical or poetic sentences in French language. It means something like color is the embodiment of light through darkness, which is a way of expressing what we have seen in this exhibition. The interpretation of the rest of the statements I leave to you. That was all. Thanks for your attention. Let me point out that the ideal colors are not possible to reproduce with any available means.